press the record button for us. Number 14, dinitrogen tetraoxide. On any of the left column. Yes.
Number 2.
Yep.
How can it be xenon if xenon's a noble gas?
All right. Remember, I'm so sorry that I said remember, because not sure if it stood out then, but when we talked about chemical bonding and we did Lewis dot structures, we had center elements that exceeded the octet. I would always tell us when that happened. Okay. So just a reminder of that we've like seen this before, and not that I called it to our attention then purposely, like here. We normally say, yeah, noble gases are non-reactive, but we can force, especially Max, the larger noble gases with pressure to form chemical bonds.
So it's like a man-made bond then.
Correct.
Okay.
Correct. Another question. Yes.
Number 12.
Okay.
Why wouldn't it be hypo? When the protein's the same thing.
All right. Now, did you say hypo or hydro? Okay. So, if your acid is hydrogen with only one other element, so that could be, Noah, HF. That could be H2S. That could be H3P. It does not matter the number of hydrogens. The number of hydrogens that are present in the formula is to balance the total negative charge that the anion brings. We need 2 hydrogens because sulfur is a -2. We need 3 hydrogen because phosphorus is a -3, and so on. That doesn't show in the name. What determines the name, first and foremost, they're acids. Begin with hydrogen, yeah? It's hydrogen with only one other element. It doesn't matter how many we have of each. Then we always attach the prefix of hydro. It could be totally wrong, but I think HCl is probably one of the most well-known acids to the average person. That's hydrochloric acid. We can rely on that very well-known one to remind us, we need the prefix of hydro, the ending of ic, and the word acid. Okay? So if you have hydrogen with a polyatomic ion, no prefix gets added on our part. But the prefix could be part of the polyatomic ion name, like HClO4. That is perchlorate. That's its name. Yeah? But whenever it begins with a hydrogen, then we change ate to ic and add the word acid. Okay? So we only attach a prefix if it's a binary acid, the ending of ic, and then the word acid. If it's a polyatomic ion or an oxyacid with hydrogen, you just adjust the polyatomic ion ending name. Okay? Did you have a concern?
Yeah, so for number 6, I know you said we can always trust that silver is going to be 1, but I put it down anyway. Would it be wrong?
It would be.
Okay.
Yep. Tyler.
For whenever you said it was binary for hydrogen,
Uh-huh.
I mean, if there's like 3, then it would still be binary.
Correct. The binary is addressing the number of elements.
But isn't that?
The number of elements. We have not the number of atoms of each element, the number of elements. We have a special name. We don't have to know this yet. We would call this a monoprotic acid, a diprotic acid, a triprotic. So we give different names to talk about the number of hydrogens that are there. But the binary means number of elements. So you don't look at the subscripts. You just look at the capitals.
It was like HEH, and now that probably can't be a thing, but would that not be?
Well, how about, I don't know.
And wouldn't that also be because you said?
So, okay, let's just say that this would exist. Then this must be some kind of polyatomic ion, even though it's not. If we don't, we wouldn't have that. So, but I want to address your question.
So aren't they all binary then, or if there's a polyatomic ion, then they're not?
Correct. Yeah.
So always, okay.
It either is hydrogen polyatomic ion or not. Yeah, there's no other category.
Well, I know there's no other category,
Oh.
but if it has a polyatomic ion, then it's always not going to be binary. It's only
Correct.
binary. Remember, it's one element, like with other one elements.
Correct.
Okay.
Correct. All right. Excellent questions. Excellent questions. Okay, so in the right column then, IO3 is iodate. We know that 8 goes to ic, so this is iodic acid. No prefix of hydro because of the polyatomic ion. Then we have calcium hydroxide, silver carbonate, tin 4, and that would be IV, yes, tin 4 chloride. Then we have, oh, we did that together, iron 2 sulfide, and 26 is acetic acid, 28 tri-sulfur heptachloride. Sorry about that. Yes. Absolutely. Absolutely. All right. So it is HC2H3O2. I first see begins with hydrogen. I know it's an acid. So then my brain asks, okay, is the hydrogen with the polyatomic ion? Yep. Yep. C2H3O2 minus 1 is acetate. 8 gets changed to ec, and we add the word acid. Is that okay?
Yes.
Okay. Other concerns? Yes.
So I'm a little confused on when we're supposed to put like the Roman numerals.
Whenever it is a metal that we do not trust the charge of.
Okay.
Yep. So there's a whole lot. Remember yesterday, highlighted this, highlighted these. So anything that wasn't highlighted, we have to show the charge in the name.
Okay. So it would just match with like the one that I was with. Like,
You determine its charge based upon the formula.
Yes.
Yes. Yes. Did that?
yes.
Yes. Yep. Other concerns? If we invest and get good and strong at going in this direction from the formula to the name, then moving in the opposite direction will just really flow more easily. So to prove that, can I ask that we turn to page 13? So I wanted to address homework, check, and any questions. So now demonstrating going in the opposite direction. And I think it is best if we go ahead and just look at our different types of compounds separately first. Okay, truly, we name compounds sensically. The name indicates and starts the formula. Okay, so Anna, Choose one of these. 1, 2, 3, or 4.
2.
All right. Magnesium carbonate. Magnesium carbonate. Ella, what would you write down when you read magnesium and then carbonate?
You mean like the formula?
Yes.
Mg, CO3.
Yes. So those are our parts. But we need to make sure that the compound formula is correct, and that's when the total positive and the total negative are equal, and we have a neutral compound. What charge will the magnesium ion be?
+2.
Yep. And what charge is carbonate?
Negative.
Oh, wonderful. Already, one of each will deliver a neutral compound. And so MgCO3 is it. We want to be writing our formulas free of charges, even though we know they're existing as charged species. Okay, so there we go. How about aluminum sulfate? Troy, aluminum is what charge, sir? Sulfate, formula, and charge. All right. Did you say -3?
I did.
See, you are such a strong student. I just assumed correct. It's -2. So, sir, think of lowest common multiple. What formula? And we need to put the polyatomic ion in parentheses, right? Because we need 3 of them. Excellent, sir. Excellent. We just take care of 4. Okay, beryllium nitride. Beryllium nitride. Megan, what would you write down for your parts? Okay. Beryllium is what charge? You got it. Now, nitride. Whenever I read 8 or 8, we know that has to be a polyatomic ion. Only those things end in 8 or 8 as anions. Some do end in I, but if it's nitride, is that a polyatomic ion? It would just be monoatomic. It's just nitrogen existing as our anion. What charge will that be? You got it. And so same thing, lowest common multiple. So Be3N2. So our name gives us our cation and our anion. It's up to us to balance to deliver a correct formula. Good? Okay. Tyler, choose one of these.
2.
All right. Now here we see Roman numerals. And Abby, what does a Roman numeral represent?
That's a metal that we don't trust the charge of.
Excellent. The charge, the charge, the charge. So here, cobalt is a +3. In number 1, that means lead is a +2. This means nickel is a +1. Tungsten is a +1. They are the charges. The charges. Okay, Elena, we'll keep going with number 2. So cobalt is paired with phosphoride. So what would that be?
Would be CO.
Phosphorus. That is not a polyatomic ion. We had to learn phosphates. Yes, ma'am.
So since we know that like it's a transition metal, so its charge depends on the next one, so it has to be neutral. So wouldn't it?
No, its charge does not depend on the anion. The charge is told to us. The formula that we create will be based on the relationship of these. This is not a +3 because that's a -3. Okay, here, nickel is +1. Sulfide, okay, that's not a polyatomic ion. We had to learn sulfate and sulfite. Sulfide, Oscar, is what charge?
-2.
It is. So do you see? Okay. What formula would result from these two ions? How do I get nickel to, yeah, very good. Yeah, yes, sir.
What's the ending change for ite, like sulfite, iron sulfate?
When it's in an acid, we only adjust polyatomic ion names when they're in acids. So to answer your question, am I okay to, or do you want to wait?
That's fine. You can answer.
Okay, so if we look at acids, okay, in a name of an acid, how do we know if it's a binary acid?
If it has hydro before it.
So as soon as we see that, we need to know, oh, that is hydrogen with only one other element. And Avi, what is the element? Yeah. 1. Fluorine as a halogen, -1. Yay, HF. All right. So then Noah, all right. These don't have hydro. So we know they're acids. They have to begin with hydrogen. They are going to be paired then with a polyatomic ion. Okay, Noah. 1 and 2 have the ending of ic. Number 3 has the ending of us. Right, so if it was ic, what originally was the ending?
Chlorate.
Chlorate's formula and charge?
CiO3 minus
Di?
CI.
What? Phew. Yeah. And -1. Great. We know hydrogen +1. We're good. This would be phosphate. And Tyler, what is the formula and charge?
PO4 -3.
So how many hydrogens do I need? You got it. Okay, so Noah, if it has the ending of us, it originally was, yeah. And nitrite is NO2 -1. We only need 1 hydrogen. Perfect. So we saved the easiest for last. The easiest. Maddie, choose 1, 2, 3, or 4.
1.
All right. Try sulfur. What does that mean? I have 3 sulfurs. Dichloride, I have 2 chlorines. No need to check charges. Isn't that so nice? The name tells us the formula. Phosphorus tetrafluoride. Let's see. Ella, could you give that?
And then F4.
Excellent, excellent. Other Ella, number 3.
NO.
Oh, remember, we won't see mono on our first one. We just have to know that there's 1. And then we'll go with the other. What about number 4?
C.
Oh, perfect. Questions? Yes.
Did you finish number 4 for transition metals?
I didn't. So tungsten +1, hydroxide. Now that is a polyatomic ion that has that I ending. OH minus 1. So WOH. We've had some interesting formulas, huh? I guess we could kind of say, whoa, didn't we have COP before? Anyway, sorry. Here's a guy, student who said, oh, that's just the friendliest acid. A little, no, okay. Look how great chemistry is. Look at all these like clever little witty things that make you smile. Concerns. So we will practice a bit of this, but now transitioning. All right. I would like us to work individually. You'll be responsible for your own data table, but you can work as a team in your work. Okay, so everyone will turn in their own, but you can work with your regular lab groups. Over the next couple of days, while we are going to be working in lab, I have my AP students doing spec work, and the instruments on this lab table and then the far side lab table, they really shouldn't be moved. And so you guys, I am going to, if you don't mind, merge you with the group. So I'm going to ask you guys to merge on the other side of Ella and Megan. And then for you guys to then, because your lab group, sorry, is taken. Again, another scar, but you'll be further from my home base, further from me, win-win for you. Okay, then, sorry, Oscar, because I caused scars in Tyler, because early in the year I used him as examples. So that's why I need to like fill you in on why I refer to that a lot. And then if you guys could go ahead and you'll work on the opposite side of Abby and Ella and Oscar there. Okay, so what I'm going to ask you to do, can each of you choose a single piece of gum? And I hope that one of these types appeals. And your job, I already have notebook paper at your stations, but feel free to come and get one of these if you want. You'll put your name on it. You'll tell me what type of gum you have. I am delivering sugared gum. It is not sugar-free. So if anyone has an opposition, totally fine. Just let me know. You're investigating and then collecting data to tell me by the end of class, what is the percent of sugar in a piece of Wrigley Spearmint or a piece of blue raspberry Hubba Bubba or strawberry watermelon Hubba Bubba? We're not reading the label. Are collecting your own data. If you want to check in with me about an idea that you have, you absolutely can. But each of us will, gosh, in 10 minutes, be able to deliver the data. So whenever we are sharing data, we want to organize it visually. If we're collecting any measurements, we know they have to have units. If you're doing any calculations, you need to show me the work and obey sig figs. Yeah. So the goal is to find the percent of sugar in one of the pieces of gum. Okay, go. Sorry.